Now we come to the atmosphere. Okay, the atmosphere that contains the air that we and the oxygen that we breathe is also composed of spheres, different layers. Again, on the left side, this shows the temperature structure in the atmosphere. Okay, it's only warm near the surface, really. Temperature decreases rapidly because the pressure decreases as you move higher up in the atmosphere. And so minus 60 degrees at the height of the tropopause. That's where the planes fly mainly. Okay, you can see a distinct temperature structure. Okay, you have tropopause as the transition zone. So that's where most clouds form. Okay, that's where the clouds form. Then we have the stratosphere, and there's something here to do with ozone. These are actually layers where greenhouse gases play a big role. With the ozone itself is a greenhouse gas and actually induces this warming of the atmosphere at greater heights. Okay, you have that distinct structure. So why do I include the atmosphere in this discussion? This is a marine science topic, but the atmosphere plays a big role for the oceans, modifies the global heat budget, greenhouse effect. It's part of the climate system also, but also plays a dominant role in the hydrological cycle, the water cycle, and climate variability. The water cycle plays a role because the rivers export water into the oceans and in systems which are known as estuaries. Climate variability also includes the ocean, like El Nino events. Okay? What the atmosphere also does, and it actually involves horizontal wind fields that drive oceanic currents. It's the winds that create oceanic currents within the upper 1 to 2 kilometers of the ocean, actually wind-driven currents. It involves horizontal winds together with updrafts and downdrafts. Updrafts are ascending air masses that go up, and downdrafts are descending air masses that go down. And these systems actually determine where you have more evaporation or where you have more precipitation in the ocean. And the precipitation influences the salinity in the ocean. It adds a fresh water to the surface and reduces the salinity. Okay, so the winds drive ocean currents, and the winds can also transport particles. Particles in some regions play an important role, like the iron dust that comes from deserts plays an important role stimulating marine production in the ocean. Okay? So there's also an exchange of water and gases, oxygen or CO2 with the ocean. That's an important thing. And so now just this table shows you the composition of air. So the most important, the biggest percentage by volume comes from nitrogen and oxygen. So that's the key components. But then we have important components which have very, very small volume contributions, but which are extremely important, like water vapor. Extremely important in the climate system. Water vapor itself is a greenhouse gas. Okay, water vapor is involved in the water cycle. We have CO2, we have ozone that I mentioned before. So very, very small and variable contributions play an important part in the climate system.